Upscaling technologies like DLSS and FSR and XESS have been surprisingly controversial lately if I read my comment section, if I look at comment sections on other channels, if I look at PC gaming Reddit places, subreddits, things like that. And a lot of this comes down to the idea that a lot of people are blaming these technologies on a lack of PC game optimization, a lack of support for older hardware, and in general, I think just a frustration with the default assumption that people will be upscaling. And so this video is going to talk about my thoughts on a wide variety of related topics to upscaling, are game devs just getting lazy on all of that? So anyway, buckle up, let's go. Now let's start with this. So first of all, why do I think people are getting frustrated and where is a lot of this coming from? So if I look at my videos where I look at the system requirements list for a lot of recent games, the system requirements lists have been basically giving the recommendation with upscaling enabled, whether that's DLSS or FSR, but you are not rendering the game at the native resolution according to the developer's recommended way of playing the game and the system specs. And this has caused a lot of frustration for people. But realistically, I think that's actually fairly accurate to how people actually use their GPUs and how game developers are planning out and delivering their games. So, but again, I think it's still true that that's frustrating for PC gamers. But what is going on here? And again, I often see the accusation that game developers are lazy, and that's what's causing this. So, I think what's actually causing this is the move to the newer console generation. And we're at a point now where most games are no longer targeting cross-platform support for the older consoles, like the PlayStation 4 and Xbox One. Most of these games that are listing, upscaling as part of the recommended system requirements are current gen console only. And let's face it, usually for most game developers, PC is a bit of an afterthought in their development project compared to gaming consoles, where they're probably going to make the bulk of their sales and they're going to focus the bulk of their development and optimization. So, with the move to the latest consoles as your default hardware, that really makes it so a lot of the games currently are not offering as much scalability in performance in normal graphics settings from low settings up to ultra settings. In a lot of games in the past, we've seen a lot of scalability there, and that's because the low settings were often targeting consoles like the PlayStation 4 or the Xbox One. So you needed to offer textures and effects and everything, and actually just the entire game design had those consoles in mind, so it constrained what you would do, the kind of environments you would create, how fast you would be expected to be traversing through areas, and how load screens would play into that. All of that was targeting those older console generations. And so if you had something like a GTX 1060, that's more powerful than the GPU in a PlayStation 4. So you're probably going to be okay, playing at lower settings and still hitting a higher frame rate than what those consoles would deliver. So you'd feel pretty good about that. However, with the move to games that are just targeting this current gen console generation, you're looking to where the lowest settings the developers are probably spending a lot of time on is whatever's going to be their performance mode settings for the consoles, like the PlayStation 5. So if your PlayStation 5 has a performance mode that's targeting 60 frames per second, it'll tweak back some settings compared to its quality mode, which are often targeting, 30 frames per second. And that's a lot of the scalability that you're going to see in the PC graphic settings. It's also possible that the PC graphic settings going up to Ultra might even offer something beyond the quality settings for the game, because if those are already pared back a bit from what the game engine could have offered, then oftentimes they'll let you turn them all the way up on PC. And then some games will add in additional ray tracing or path tracing options that PC can handle that the consoles can't. So you can oftentimes see it scale up from there, but a lot of times, again, I think nowadays we're seeing the low settings targeting what the consoles can do. And speaking of consoles, the game developers seem to be choosing Resolution scaling, oftentimes using AMD's FSR2 upscaling, which runs on the game consoles, sometimes with other in-house solutions or in-engine solutions, in order to render the games significantly lower than their actual output resolution they're targeting. Oftentimes well below 1080p internal rendering resolution to then give their final output, especially in performance modes. And if you follow Digital Foundry, for example, they'll often give you the internal rendering resolution that they're seeing these consoles running at. And if you look at their performance modes, again, it's often extremely low internal resolution and then upscaling past that point. So the game developers, and everybody usually agrees that games are more optimized on console than they are on PC, but they're choosing upscaling as one of their prime optimizations that they are making. So let's talk a bit about optimization and if games are, being less optimized. Well, what is optimization? You are optimizing usually on two variables. In this case, what we're primarily talking about is the final image quality output that you're getting and the hardware demand that it's costing to get there, right? So you are trying to optimize the output image resolution and frame rate. How good does it look and how well does it run given a certain level of hardware that you have to run on, right? So they're optimizing for the consoles, and what they're choosing to do is to increase the level of graphical fidelity, effects, sometimes ray tracing, sometimes some really good lighting techniques that might be more of a software-based ray tracing global illumination feature, high-resolution textures, large environments. All of those things have a cost, and to make them run easier on the GPU, they turn down the internal rendering resolution of the game and then upscale it using something, oftentimes FSR2. Now, it's true that you'll often then get a kind of a bit of a temporally unstable image. It might be kind of shimmery, especially in motion as, for example, a character moves across the screen and an object is disoccluded, meaning it wasn't visible previously. Oftentimes that what's uncovered looks very unstable, not that great. But the game developers are choosing between basically the quantity of pixels that they can offer, which helps out with those stability issues and the shimmering and things like that. The more resolution of internal rendering pixels you give it, the better, the more stable those elements will be. But by choosing to lower the quantity of pixels rendered internally, they are able to increase other graphical settings, and they're making the choice that they feel like the final output is better by lowering the rendering resolution in order to increase other elements of the graphical fidelity. And that brings us to PC, where at least in the comment sections, I'm seeing a lot of pushback against this idea that's like native resolution or bust, and that's really interesting to me because, going off on a bit of a related tangent, I'll tie these things back together. It's also generally accepted, if you look at comment sections and general advice in PC gaming communities, that gaming at maximum preset settings, like Ultra, for example, is generally kind of dumb, and that going down to something like maybe the high preset will often offer you almost the same visual experience, but at a higher frame rate. It's easier to get there. That's often going to be the best way to go. A lot of times people say like Ultra is for screenshots, high is for actually playing the game. But just think of the resolution scaling as just any other graphical setting, where rendering the game at 100% internal resolution scaling will look the best. But if you pull that back from 100% of your output resolution and lower that internal resolution scaling, as long as you don't go too far, it looks extremely close to the 100% rendered image, but with dramatically improved frame rates. And that's another thing that we're seeing in some of the latest games, especially Unreal Engine 5 games, is that they are responding extremely well from a performance standpoint to lowering the internal rendering resolution scale. And that could have to do with the types of per pixel effects that they're running. In Unreal Engine 5, you have things like nanite and lumen, and I think the amount of like probes, the amount of geometry is heavily based on the number of pixels being rendered, and so if you pare back the number of pixels being rendered, you're going to dramatically boost the performance, whereas other effects in games aren't always rendered on a per pixel basis. So in other games, you won't see as dramatic of scaling going down to like the quality upscaling setting, that kind of a thing. So in other words, I really think that there should be more of an acceptance of resolution scaling using DLSS, FSR, XES, things like that, as just another graphics setting. And it's kind of similar to the ultra versus high settings. You've got rendering every single pixel 100% resolution scale versus rendering, 70% of the pixels per axis can often look extremely close to that 100% scale, but deliver dramatically better performance. And so I really think it's interesting to me that a lot of the same people that would play at high settings instead of ultra and say it's almost stupid to play at ultra are the same people who might argue against a resolution scaling. Now, I will say it is a bit frustrating to see in something like system requirements lists, because then it can be harder to judge the relative performance that you're going to get, and not everybody is okay with the same levels of upscaling, things like that. And by the way, I'm not even talking about frame generation at this point. But then I think another reason why this is causing a lot of drama in the PC space is that not everyone has access to the same upscalers. And that's, I think, a big part of the problem and where a lot of the frustration comes from. NVIDIA's DLSS upscaler is significantly better than AMD's FSR2, and Intel's XeSS upscaler, while that's available in fewer games, it can have better image quality than AMD's FSR2, although usually it's not quite up to par with DLSS either. Now, on a game-by-game basis, sometimes the gaps between them can vary, sometimes they're very close. And especially between FSR and XeSS, I think sometimes it can bounce around. So it's not really usually too much of a difference in terms of the performance that you're gaining, especially when comparing DLSS and FSR. They have a similar performance cost and performance benefit. But the image quality that you end up with can be very different. And so I think for people who don't have, just being honest here, I think for people who do not have NVIDIA's RTX GPUs, which run DLSS, it can, so either if you're on an older NVIDIA GPU or if you're on AMD or Intel Arc GPUs, it can be frustrating if games are going to be designed with upscaling in mind because you don't have access to the best quality upscaler. Now, that being said, the consoles are mostly using FSR2 a lot of the time, or when they're not, they're often using maybe Unreal Engine's temporal super resolution, TSR, something like that, which is available to any GPU and runs about the same on all of them. But if you look at a detailed image quality analysis, a few months back, Hardware Unboxed did an excellent one looking at tons of games comparing FSR and DLSS, upscaling, again, not frame generation. In the vast majority of situations, DLSS is delivering better image quality. And it's also pretty generally agreed upon, this is what I see in my own personal use and testing, this is what other channels have seen, that the lower your output resolution, so your monitor resolution, the lower your monitor resolution, the less pixels you're working with, and the larger the advantage from an image quality perspective DLSS has. Or if you're rendering at a higher, maybe monitor resolution, the more aggressively you use the internal render resolution scaling, meaning the lower your internal resolution. So if we're saying like performance DLSS at 4K output, which is a 1080p internal rendering resolution, versus performance FSR2 at a 4K output, again, using that same internal resolution of 1080p, you're generally going to see a pretty significantly more stable image from DLSS, with more detail, especially in motion, especially as objects are disoccluded, and generally just a better experience with that DLSS setting. It's just better. And so again, I think that's where some of the frustration comes from here. And so I think, well, it would be nice if we could have a, vendor agnostic upscaler that was maybe just somehow a part of, I don't even know how all this works, like DX12 or one of the major game engines. I mean, we do have TSR in Unreal Engine, but the thing is it just doesn't deliver as good of results as DLSS does. So while it's frustrating that that is locked down to certain GPUs and not others, it is delivering the best results. And so I think that that's where a lot of the frustration comes from for a lot of people. Now, I think another place that frustration is coming from is because I think for a lot of people, when you're not able to run a PC game at the performance that you're looking for. So for a lot of people, that's at or near their monitor's native resolution and at a high frame rate. Most PC gamers aren't going to be happy if you're below 60 frames per second, whereas a lot of console games are limited to 30 frames per second, or they offer maybe a 60 FPS mode that doesn't always hold 60 FPS and often makes a lot of image quality compromises and render resolution targets to hit there. On PC, because you're controlling with a mouse, it's a lot more of a one-to-one motion with your hand. It's a lot more, you're wanting that instant response. And so I think on PC, higher frame rates are more important when you have a mouse input for feeling good. Plus, it's just a standard that we've hit. And so when people aren't reaching that, it can be really disappointing. And so also, I think in terms of image upscaling, I think because you sit closer to a computer monitor than console gamers do to a TV, when you're sitting a long distance from a TV, even if the TV is fairly large, sometimes those image upscaling issues that you see, the little bits of shimmering and little losses of detail in motion, for most people sitting a long distance from the screen on a TV, it's gonna be harder to pick out those little details. Whereas if you're sitting very close to a monitor, as a lot of people do when playing PC, I think it's easier to spot those issues. And so again, I think the rendering resolution issues are a little harder to tolerate on PC, again, depending on how aggressively you're using them. So I think because of that, a lot of people are just generally frustrated with the performance they're getting out of these new games. And honestly, guys, a big part of that, like I said, is because the consoles are now, we're looking at PS5 equivalent or better, right? For the kind of hardware these games are looking at. And that's a big jump compared to when we were only looking at like PlayStation 4 level hardware for the targets. But I think what's adding to this is the fact that PC gamers would usually be, okay, maybe I'll upgrade. So maybe I had a 10 series GPU, maybe you buy a 30 series GPU. The problem was we had the whole crypto mining boom, making a lot of 10 series GPU owners not able to upgrade to a 30 series GPU because the prices were absolutely insane. RTX 3060s were going for nearly $1,000. 3070s were going for $1,000, sometimes more. During a large chunk of the 30 series generation and AMD's 6000 series generations similarly. But now we're on to the next generation where a lot of those 10 series owners would really like to jump to an NVIDIA 40 series or maybe a AMD 7000 series. But the problem is you're not getting a massive generational jump between the 30 and the 40 series. Or maybe someone bought a 20 series, and so now you'd normally buy a 40 series. Again, you're not getting this big jump in performance between the 30 and the 40 series like you would normally get, and oftentimes the prices went up too. So for example, if you're buying in the kind of the mainstream, actually I think upper end of mainstream might be like a $400 graphics card. So maybe you were finally able to afford a 3060 Ti when prices went down, back to the actual MSRP of around $400. And now maybe you're a little frustrated your 3060 Ti isn't quite hitting the performance that you want. So maybe you want to buy a 4060 Ti. Well, the 4060 Ti isn't much better than a 3060 Ti. And there's even weird obscure cases where, maybe at a higher resolution that's really memory bandwidth heavy, where it even is regressive in performance and performs worse. And it's at the same price. So at a lot of price points where people are actually buying, there has not really been a large improvement in price to performance between these two generations. And so that is causing, I think, a lot of this frustration as well. Is a lot of times the answer is, okay, just upgrade, but there's not a lot of great generational uplift there. And people have been stretching their upgrades longer than they would normally due to that whole crypto boom that we saw. So, if I want to look into the question, like, so is native resolution dead, right? Because I've been seeing that. Is native resolution dead? Well, I think that until we get at least another generation, if we actually get a big generational price to performance uplift of GPUs, in the current generation of GPUs, while many of them are stronger than consoles, consoles are relying on a lot of upscaling, sometimes just to hit 30 FPS, and definitely to hit 60 FPS in games. And that already is kind of at the lower settings that the games are now offering because, they're targeting these consoles as that kind of lowest end of the settings that they're willing to develop. So what that means is you need a GPU significantly more powerful than the consoles to run games at native resolution, 60 frames per second, at fairly high settings in the latest, most demanding games, right? So because those GPUs are so expensive right now, that means that a lot of people really should be upscaling. And even if you have one of those more powerful GPUs, oftentimes you'll need upscaling if you want to hit high frame rates. Because again, you're going to need something pretty powerful just to hit 60 FPS at max settings, 1440p, something like that in these latest like Unreal Engine 5 games, Alan Wake, things like that. So again, you really probably should be looking at upscaling. So is native resolution dead? Not necessarily, but it's like running at the ultra settings. Like I said, it's kind of a luxury if you have extra computational power to throw at the problem, which means you have extra dollars to throw at the problem. So if you're using a 4090 at 1440p, maybe you don't need to upscale. But even a 4090 at 4K is probably usually going to want to use DLSS quality if you want to max out the settings in games. And maybe even more than that if you're maxing out like the path tracing monster games and things like that. So as GPUs generations come out, if consoles, if we don't get a new generation of consoles, right, then the console targets that the game developers are trying to hit for those lower settings, the console performance mode settings, those are going to be kind of a fixed target. And our GPUs will eventually get better when we get that 50 series from NVIDIA and the 8000 series from AMD, and hopefully Intel offers us something awesome from Battlemage. The PC hardware will continue to progress beyond where consoles are at. Hopefully the prices don't increase with them. That's what we really need to see. And then it will be more affordable to buy hardware that doesn't have to upscale. However, you really still might want to, and I really think AMD needs to improve their upscaling technology. Again, I'm not talking about frame generation here, the actual baseline upscaler, to be more in line with what DLSS is able to offer. I think AMD might need to bite the bullet and offer an AI-trained, machine learning-trained algorithm for upscaling. XeSS is doing that. Intel understood that they had to do that right out of the gate, and they have offered that with hardware acceleration from, matrix multiply and accumulate, cores, actually built onto their GPUs. And the big problem for AMD is they might have to break that backwards compatibility, which is the strength of FSR2, onto all of the GPUs. But in the end, if games really are going to be relying on upscaling, and if upscaling is one of the best ways to improve your performance, if you're getting a worse image quality when you get there, that's a serious problem for people looking to buy those GPUs. Now, currently, AMD kind of offsets that by offering more performance per dollar, at least when you're not ray tracing, which means that maybe you can make up for not upscaling by just getting a more powerful baseline hardware at the same price, and that's kind of how they're dealing with it right now. But if AMD ever wants to be able to sell for about the same price as NVIDIA does, the upscaling quality is going to have to take a major jump, or else they're always going to have to be competing on price. And so that's really something that I think we need to see here, because in the end, even once the hardware is more powerful than consoles to the point that you don't have to upscale, you really still maybe should, at least at the quality settings, because of the optimization you're getting in image quality, loss. There's a loss to the image quality when you have less internal pixels rendered, but there's a gain to the frame rate, which can be awesome, and it's going to be one of the best ways to gain that frame rate. And so I really think that upscaling is definitely here to stay, and I think it will continue to be the case that native resolution scaling, 100% resolution scaling, is going to be a luxury akin to running a game at max settings versus tweaking things down, where oftentimes it is not the optimal way to go. Because really this is just taking advantage of the fact that two frames in a game are often very similar. So using temporal data, using information from the previous frame to inform your next frame is a much more efficient computation to reach a very similar output, output image than brute force rendering every single pixel from scratch every single time. And in this video, I wasn't even talking about frame generation, which is another step on that, where you're actually interpolating two frames, but that's really a different thing. That doesn't gain you more actual responsiveness to your game, although it does increase motion fluidity, and that's really a topic for another video, considering how long this one already is. So this was a lot of me rambling on this topic, but in the end, I think if we want to kind of summarize my main points, I don't think that this reliance on upscaling is necessarily a laziness on the developer standpoint. It's just a consequence of the game developers are focused on consoles, and so they're no longer required to target as many generations as consoles. They're targeting the current generation of consoles, and most of their game settings are going to be targeted at the performance mode and quality mode that they're going to offer for consoles. So they're not going to offer a lot of scalability back from that point. And because modern upscalers have gotten so good, it's oftentimes the best optimization they can make for their console game to target offering more graphical fidelity at the cost of the number of internal pixels rendered. And I think some games push that a little bit too far. They're asking a little bit much from FSR 2. But that is the choice that they're choosing to make to give the vision that they want to. And I think that's going to continue to be the case. And so until PC hardware is affordable to a point where you can just massively outperform a PlayStation 5, massively outperform it at an affordable cost, then I think upscaling is still going to be a thing that you'll want to be doing on the PC as well. I don't think that's going to change. And in the end, we're getting to a kind of post-native resolution point in graphics. I really think we're at that point where rendering a game at its native resolution does produce the best output image, but it is not the optimal way to render the game. And as a consequence of that, I do think that AMD needs to seriously work on, and hopefully they already are behind the scenes, improving FSR upscaling to be able to compete with DLSS upscaling at the more aggressive settings and at the lower resolutions, because I really do think that that is the future. We're going to continue pushing graphical boundaries at the cost of the game's internal resolution, relying on that temporal data and that reconstruction. What do you guys think about all of this in the comment section? I'm not so much trying to come down on this as like it's good or it's bad. I'm just trying to say, here's what's happening and why I think it's going to continue to happen. And how I think that affects the situation overall. Did I capture your thoughts on this? How do you feel about all of it? Let me know in the comment section, and I hope all of you have an excellent day.